Hello everyone, welcome back to Enduring Ideas Forever. Today we are diving deep into Python lists. We will cover everything what lists are, why they're useful, and all essential methods you need to master. By the end of this video, you'll be confident using lists in any Python project. Let's get started. So, what is basically a list in Python? A list in Python is a collection of items. The items could be data like numbers, strings, and lists themselves. So, lists are usually ordered and lists are usually mutable, meaning we can change their content once they're created. So, an example list would look like this. My list's name is called my list, and I am keeping some numbers and strings inside it. So you could see that I've inserted A, B, C, and 1, 2, 3 in my list. So if I want to print my list, I would write print of my list name. Here, in this case, my list name is my list. So it would print. Lists are very flexible and one of the most commonly used data structures in Python. So, how to create a list? We could create a list using uh, the square brackets like this. Otherwise, we can use the keyword list of. So, let's say uh, I want to create a list called nums. I could either create nums like this, or I could also do like nums equals to list of 1 comma 2 comma 3 comma 4. So both will essentially give the same result. They will create a list. So now we will see how to access elements in a list. Let's say I have a list nums 1, 2, 3, 4 that contains 1, 2, 3, 4. So I will access my list using indices. So, as we all know, 0, 1, 2, 3. These are the indexes of nums. In computer science, the basic fundamental is that all the iterables will start from index 0 unless mentioned specifically. So, uh, how do I access one here? It could be accessed with nums of 0. Nums of 0 is 1. And what about nums of 2? Nums of 2 is 3. What about nums of 3? It is 4. So, what about nums of 5? It will raise a error because it doesn't exist in the list. So that's how we access it. So, modifying lists. Since lists are mutable, we can change elements, add elements, remove elements. So let's say I am initializing a list called fruits, and the list has these elements in it: apple, banana, and then orange. So these are my elements in my list called fruits. So now I would like to replace uh, banana with strawberry. I would simply do fruits of 1 equals to strawberry. So now if I print fruits, this will automatically be updated. So in order to modify list, we would use the index and then we would assign the thing that we would like to replace. So that's one kind. So what if we wanna add an element in the list? Adding an element in list. So let's say I have a list called A and it has the numbers 1, 2, 3, 4 in it. Now, there is a method called append whose signature looks like this. So, if I write a dot item, sorry, a dot append of 5, the list will look like this now. 1, 2, 3, 4, 5. This is one way of appending. Appending means the item in the last, adding the item in the last. And now, what if we want to add an item at a specific index? We use the insert method. So the insert method looks like this. This will adds x at index I. Again, insert method specifically is designed to be used with zero indexing. So this is one good thing, basically. So the next one is extend. Extend of item. If items actually, if we let's say we have a list called 1, 2, 3, and the name of list is A. If we write a dot extend of 4, 5, basically now my own A will look like this. So this is how we extend a list. Now, removing removing elements from a list. So there is a straightforward method remove of item. Let's say I have a list like this 1, 2, 3. If I do a dot remove of 1, remember this is the item, not the index. So my new A will be like this, A equals to 2 comma 3. So that's how it works. We have the pop method, pop of item. So what happens to pop? What's the difference between remove and pop? Pop also basically removes it, but pop only removes the last one. Unless item is given specifically. If the item is given specifically, the pop method will remove the item. If there is no item given, the pop will remove the last index, basically. So there's one more method called clear. If I have a list 1 comma 2, if I do a dot clear off, then my new list will be basically empty. So this is the use of clear off in lists. And there are a lot of useful methods in lists. So now we're going to see some useful methods in lists. So index of item. This this is basically the function looks like. So let's say I have a list called a equals to 1 to 3. Now, if I wanna print a dot index of 2, that means I am basically printing the index of 2 in the list A. What will this print? This will print 1 because the the number 2 is at index 1 in the list. So that's how it works. And then we have the method count of item. So let's say my list has 1 comma 1 comma 1 2 3. If I print a dot count of 1, that means the count of method will count how many occurrences of 1 are present in the list A. So basically the output will be 3 because there are 3 occurrences of ones in the list A. And as we all know, sorting is one major thing in programming. So, how do we sort? Uh, in Python, it is basically very easy. So, let's say we have a list A equals to 3, 2, 1, and the method is directly sort of. So, if I do A dot sort of, my list will be like this. My list will be looking like this. Unless we give reverse equals to true as a input parameter in the sort function, the list will always be sorted in in an ascending order. So what if I want to sort in descending order? I would just write reverse equals to true. That's it. And that's how it gets sorted in the descending order. So the next one, copy method. Copy is one good method in Python which saves a lot of time, especially in competitive programming when we're falling short of time. Remember, it's time, not time complexity. So, um, I have a list called 1, 2, 3, and then I make a list b equals to a dot copy of. Now, if I print b, it is basically nothing but 1, 2, 3 again. Essentially, I'm making a copy of A. So that's copy of. Now, iterating the list, this is one good topic. Basically, how do we iterate a list? For the matter of fact, we use a for loop or a while loop in Python. So let's say I have a list called my list. My list equals to 1, 2, 3, and then let's say I want to print all the elements in my list. For I in my list, print I. This basically prints out everything. So the output would somewhere look like this. So this is how we iterate it. Or if I want to use a while loop, while I less than length of my list, print my list of I plus plus. Oh, I'm sorry. It's I plus equals to 1. So the output will be the same 1, 2, 3. That's how we iterate lists. Uh, okay. Now nested lists. This is a very good concept to learn. Nested lists. This this can also be treated like multi-dimensional lists. So let's say I have a list A. This is my original list. Let's say I declare a small list containing 1, comma 2, comma 3 inside this, and another list containing 4, comma 5, comma 6 inside this, and another list containing 7, comma 8, comma 9 inside this. So what does this say? Look, this has three sublists in it. This has three sublists in it. And then this can also be written like this, right? So now if I wanna access the element 3, how do I access it? See, this is the zeroth index. This is the first index. This is the second index. In zeroth index, this is the zeroth index. This is the first index. This is the second index. So a of 0 of 2 equals to 3. This is how I access it. Suppose let's say if I want to access 9, this is second index in the original list. So a of 2 and then This is zeroth index, this is first index, this is second index. So this is A of 2 of 2. This is 9. This is how we usually usually access multidimensional lists. So to summarize, in the end, lists are usually ordered, mutable, that means we can change the values once they're created, and they're flexible. We can access, modify, add, remove, iterate through lists. So, believe me, list is the most used data type, data structure in Python. Lists also support nested structures, list comprehensions. Mastering lists is crucial since they're foundation for many Python projects. Okay, thank you for watching. If you found this video helpful, please hit the like button, subscribe, turn on notifications for more Python tutorials. Thank you so much.